Hello, welcome to my bench. If this is your first time, hi, my name's Dave. I fix electronics, mostly radio station stuff and some ham gear. You're welcome. Hope you go and hit that register button or subscribe button and the little bell so you know when I'm doing more of this stuff. And if you're coming back, hi, glad to see you back. Today we've got a Compellor 320A. It's an Aphex Compellor. These are pretty well used in the radio industry and in recording studios and other stuff. They're quite a nice little unit. They're sort of a compressor expander. They are. And they also have the ability to link the sides together, and also a stereo enhance button, which kind of broadens the stereo out a little bit. Basically, what you do is you feed it what you want for audio. You give it the amount of drive that you need. I've done one of these before, I think, on the channel. You take the output to what you want to set it to. There's a switch in the back so that you can turn it from -10, +4, and +8. How much compression you want. All the way over on one side, you've got just a leveling. This is the slow and fast leveling control. And on the other side is all compress. So you want the balance between those two that you think sounds good. And it also has a silence gate, which will gate it off so there's no audio, depending on where you set it, between 0 dB and -40. It gets rid of that wall of sound thing you got in the 70s, where if somebody quit talking, then all the noise would come up, and as they start talking, it'd drop back down again. That gets rid of that. And it also has a limiter. So if it hits peaks too hard, it'll round them off. It's a slope limiter, soft, for both channels. And they work pretty well. They've been around for quite a while. I don't know when this one is. The complaint that the guy had when he sent it in was that it had some weird sounds on the left channel when you gave it audio. So we're going to find out what he was talking about. So anyhow, let's where is it? Let's get the function generator on here. Got it set up for 400 hertz at 3 volts. I'm feeding both sides exactly the same thing. These two here. They come in through a little combiner guy here, 2 outs, 1 in. Just so we've got something to compare to. I better turn this on. Okay. And let's see. You can see by this the video of the scope. This is what we're feeding it, and both sides look alike. These are bypassed, so if the electric goes out or the thing goes poof or whatever, it'll just bypass this thing altogether, and you still got audio on the air, which is a nice thing. So, let's turn this on. It is now on. It did not do anything, which it shouldn't, because I haven't got it turned. I haven't got the functions turned on yet. So here's the right channel, turn it on. Here's the left channel, and turn it on. Put the meter is in. Right now, that's output. This is gain reduction. How much gain reduction it's doing. These knobs, these are not perfect, these knobs. You're never going to get these two lights to light exactly perfectly. But you can. There. turn one click up. It has a lot to do. You can see it go through its gain reduction. Well, it also has this DVG, which means I'm functioning and working. And I'll go out in a minute. That tells you when it's reducing its input level. So, but from the little camera here, we can see that nothing happened to the output. They're pretty much the same. A tiny bit difference, but they're pretty much the same. Well, he did say that it happened when you hit it. So let's get the function generator back up here, and we'll turn it off. Okay, so now it's off, as you can see on the screen, and now we'll hit it with 3 volts. That's interesting. Did you see that top one there? That's channel 1. That's the left channel. We turn it off, let it set for a minute, hit it again. That's not exactly right. I'm on fast or slow. Let's put it on fast. See if that makes a difference. Yeah, faster, but it's still... That's weird. Let's let it set for a minute. And meanwhile, we'll go over and take a look at the manual. This is the block diagram for a 320. This is a 320A, but they're real close. I mean, there's a few differences in them. The 320D is almost the same also, but it has a little digital board in the back. I think I showed that on another video. Anyhow, so basically, you got your audio, comes into your XLR, goes through your RF, clean it up, get rid of stuff, goes through an amplifier, then to a VCA, voltage-controlled amplifier, unless it is bypassed, and it just goes right out through this relay out to the output. Just zoop, right straight through. They're hooked up in parallel. So it comes through here, goes to the output, goes to the balanced line output here, which is a, what do they call those? The word just escaped me. Yeah, I love it. The servo balanced outputs. So there's no transformers in here. But it also taps off up here, goes down through all of this stuff. In here we've got the stereo enhance, which does its little things. This is showing one side of it. And it also goes up through this little block right here. Goes into the process balance control, the thing up here. Has a compression side chain, not the side chain you're thinking about out the back of the box, like some of the things where you can like plug things in and go through them and come back in as a side chain. This means internally as a side chain because it's off the side of here. It has a compression side chain and a leveling side chain, depending on where you've got your process balance set. That goes out into what do you call this? This is DRC. This is the DRC here, and it depends on the amount of drive that you give it on the drive pot. That goes back out to the VCA and controls the how the VCA responds and how fast it responds to maintain the balance that you want, depending on whether you want leveling or compression. And this down here links to the other channel. So from there it goes to the outputs and also goes down to the display, the LED displays on the front, which are individuals, and they're driven with 3915s and 3914s with bicolor LEDs. So you'll see the 14s run the reds and the 15s run the greens, I believe. I could be backwards on that. But that's how this thing works. So now we've explained that. Let's go back up here, and we've got we still recording here? Yeah, we're still recording, I guess. And let's give it some audio and see what happens. And let's give it 3 volts and watch what... Holy Hannah, did you... Look at that. It comes down, went below it, and then recovered slowly. I'm on a 100%, just, no compression at all, just leveling. So, let's take that away. It went away. Let's try it again. Ooh, it did it, but not to the extent it did before. Holy smoke. Okay. All right, well, let's get rid of that input for now. Take the top off. I already pulled the screws out the side of it. You don't need to see that. Anyway, this is the inside of it. There's an audio board underneath these two. The audio board has the relays on it and the audio amplifiers, the VCA, and the other stuff on the bottom. But all the super magic stuff is done up here. We'll go to the schematic. I think that's what I'm... No, not quite. All right. This is the schematic for... Here. This is the schematic for the actual box itself. The bottom board. As you can see, it comes in here, just like it said on the thing, and goes right out through this relay if it's not energized. But then it also comes down through here, comes out of this U101 on the bottom board, and over, around, and down and through, and ends up coming into this U102, which is NE5532, back out and into N1 of the VCA. N2 of the VCA comes directly off that line. So you've got a difference between these two. So that your voltages are different inside the voltage-controlled amplifier. Comes out of out 1, out 2, and into this NE5532. And that goes out to some feedback here. But it also goes to H101-2, I believe. Yeah, 2, VCA out. If we go, now this is all working, or we wouldn't have anything out of here at all. I mean, or something awful. This stuff is all, both channels are identical on the bottom board, but we have audio coming out. So we know that this board is working. The only problem that I see, I think, is that the VCA on the left channel, or number 1 channel, has... coming out of pin H101, 8 or 6, 6, is the VCA V control. The voltage control pin comes in here and ends up going to pin 9 on the VCA, and that's what controls it to what it actually puts out here to go back out to the other board. So we'll go down to the other board, and this is the best schematic I have, the only one I could find. This is actually for a 320, not a 320A. There are very few changes on it. I want to make sure I'm still recording. Yep. All right. And this is our H101. let's bring this up a little bit. As you can see, it looks absolutely horrible. Here is your pin 6 for your VCA control. It comes down through this mess here into, I think that's U105 or 106. I can't remember. I think that's 105. It's really hard to read. And your VCA output comes down, and it drives this going into your compressor detector, and also depending on where your process balance is, up through your level detector up here. I think there's something wrong with the level detector for channel 1. I mean, from what I just saw. Let's go back over here and bring up the function generator, and let's try this again. Let's give it 3 volts and see what that channel A does. It just goes clean off screen and comes back down. And then goes down and expands and recovers. Phew. Okay, that's a weird one. The lights on the front are doing exactly what they're supposed to do. All right, so let's do a little bit of tracing. I'm going to try this silly scope here on the on-screen scope. It's not doing well today. They do give you a ground over here. That's nice of them. So, all right. So let's see. With scope, dink. There's the scope. Any chance you're going to work? Yeah, I guess, maybe. All right. What have we got? You can't see the manual if you want to see the scope at the same time, and you want to see me. I can't do all 3 of them. But let's start with the leveling detector. Let's go. What do you got? You got a. It's all in level. That's where I want it. I want to go to U103. Looks like 103B, where all those diodes are. So that would be 103B, pin 7. Do I have anything there? I got DC on pin 7. One is up here. Okay. Speed's all wrong. And come on down. Thank you. And it doesn't. This software is pretty awful when it comes to triggering. All right, so there's the output of 101, which is the actual input to the balancer, the process balance. But then if we go out to pin 7 and 103, just following along, that's what we got. That looks, well, sort of fine. I mean, they're not passing audio here. They're doing it. That little thing with all the diodes on it that you saw, that's a DC converter. It converts the audio to DC with a very complex display. And that comes out to 104B, which is 7. Okay, see what I said? It just stripped the bottom off of there because all they want is positive pulses. That looks about right. If I take the function generator here, get it back up so I can see it, turn it off. Yep, it went away. Okay. All right, so let's try that again with the function. We'll turn it on. We'll watch that and see what it does. See if it probably, the way it looked, it's probably going to go way up and then back down again. So here we go. And it did. And it's having a hard time fighting its way through. Okay, well, let's go for a little bit farther. We'll go on the other side of that. That's U104. Let's go U104A. And there is my yuck A signal. That's kind of nasty. What is it? Okay, that's supposed to be, let's see if I can drop this again. There, I dropped the level. It should be this sort of like it's a square, basically a square wave where they change the duty cycle of it, and that tells the speed, how fast to drop down the level as it turns on a couple of transistors here. I've worked on several of these things now, but this one's something I've never seen before. So let's turn it back on and see what it does. See it there? That's what it's supposed to actually do. If we look at the other side, which is identical, stuff's in different places, but it's identical. There's the other side. But let's get rid of the input again and bring it back. There. So it didn't go. You saw it didn't go through that stuff. So this side is not dropping down, which we saw on the little camera here. Keep checking because I don't know if it's going to stay on. All right. Well, what is next? Okay. So we've been here. We got to here. We got to here. That's 104A. So then we got to go. This is your speed selection. Okay. Well, all right. So that's about right. There's no DC voltage on 104A. No, there is not. So what do we do now? So now we go through this, which goes through, let's see, and the output of this 105, which is this one here, so that's 105 pin 1, that is a voltage, that's a voltage dropping down. What the? Let's get rid of this again and bring the scope back up for you. All right. I'm going to give it some more, give it voltage again. Give it some audio, and we'll see what that does. Right now, what the? See that thing creeping down? I'm getting a negative voltage on the output pin of U105. Let's look over here at 105 on the other side, and its output pin is 0, which is what it should be. 3 are the non-inverting input, non-inverting input, and there's the other input, negative almost nothing. I mean, that's fine. I mean, it's picking up in the probe here. But on this one, we got negative, holy Hannah, 2, 4, 5, and still going down. There's nothing there on pin 2. And pin 3 kind of it bounced. All right, so what happens if I give it audio. What this should do is it should bounce up and then come back down again and level off at 0 on the output of this pin. Because remember, it's an op amp. It should, whatever the inputs are doing, it's going to try to do its best on the output. And I don't believe, I think, yeah, this is, yeah, it's just a follower. There's nothing, no amplification there on this. It's just a buffer. So, back with the scope, and back here, I'm on it. Let me give it some voltage, and we'll see what this pin 1 does. Boink. It went from 0, went from negative to positive, and back down. And went back down to 0. That's the output. The input is still high, but it's creeping. Okay, so it just dropped. And this one's dropping. Still. Let's, there's 100 millivolts per division. We're at about 400 millivolts plus. This one is at about 300 millivolts. Did you? That was weird. Okay. This is not acting like an op amp. All right, let's put the cap in here. So I'm not giving it. I mean, we're not going to see any voltages now. Okay, this is strange. Let's take some voltage readings. See what I've actually got DC-wise on this. Let's bring in... Where'd it go? There. There's the meter. Alright, so we're still feeding it voltage or audio. We've got 0.37 volts, but it's evened out now. That's on pin 1. 3.7 on pin 2. 3.7 on pin 3. We go over to this side. We got 2.7. 2.7, 2.8. However, one more time, let's take the, this is just strange. Let's take the voltage away. This should crawl, I'm on pin 1 of 105. Yeah, now it's gone negative. And it's creeping up negative. It's going more and more negative. This one over here, it's sitting at plus 0.27. Yep, that's right. And this one, negative 1.9. Whoops. On 3. Negative 1.2. And negative 1.5. What the? That doesn't make any sense at all. All right, we're going to pull this guy. What is this? LF353. Let's test it. Okay. Says it's a TLO 82. Okay. Well, there's a bunch of these things in here. Let's just grab another one. Test it. This is in part of the meter circuit, so if it doesn't work. That says it's a TLO82 also. Okay, well, let's put this one over here. And put this one over here. Alright. So I just swapped these two around. This, if we go over here to the manual, I'll show you. This 5 here, it also, the other portion of it, if you see this where it says L, well, there's LC and something else. They're voltages that go into a ladder. Here, I'll show you. Goes over here into this other side of U108, 1008, I think, or 6. 6 goes into 106B. So pin 7 is the output, and this regulates. If you see where it comes out here on the negative side, it comes out, goes back over, goes to the VCA control. So basically, what this thing was doing, or is doing, it is doing what it's supposed to do, but it's doing it way, way, way too much and way, way, way too slow. But it also did it. But it's also, it's not only doing the leveling, it's also doing some compressing and some expanding. All right, well, anyhow, let's go back to with the scope. Well, no, this scope over here. We're still recording. Cool. Let's get rid of this. And we will just go and give it some voltage. And give it some audio, and watch this little scope over here and see what it does now, because we've waited. It's turned it off. Turn it on. It took a minute after I turned it on for this to do this. Okay, so we'll give this a little time here to settle down. While we're doing it, let's think about this. This chip went like it's supposed to when you turned it on. However, after a while it went negative. So it went negative. That means that when that went negative on the output, this L voltage was negative for a while until it rose up to where it's supposed to be. So the output of this, negative with response to ground, so the output of this is going to go very high back to the VCA. All right, well, I think that's enough time. Let's watch the little scope over here, and I'll give it some voltage or some audio again. Let's see what it does with this chip in here. That's what it's supposed to do. What? But that thing tested good. It tests good once it's up and running. Alright, so what does it do on compression? I took the audio away. Let's take it down onto compression. And it shouldn't actually do any kind of a bounce, that little up and down thing that, where it gets bigger and smaller because it's on compression. So let's give it 3 volts again. A little bit, very fast. Am I on fast? Yeah, I'm on fast. Let's put it on slow and see what it does. Okay. There. Yeah, that is what it's supposed to look like. If we take it back over here, I didn't change this right side. If I take it back over to here and get rid of the input and hit it again, yep, there it is, right there. Just exactly what it's supposed to do. Okay, let's take this one back out of here. Proving a theory here. This is weird. Just weird. This is where knowing what op amps do and how they do them comes in real handy. Alright, turn it back on. Blink. Alright, there's on. Take away my input and let it sit for a while, because it takes a while for it to do it. But let's see, what do we got here for voltage now? Dropping very slowly, dropping, and it's going negative. We saw before, it'll go negative all the way down to negative 5 volts. And this side on 105 should be about 0.2 something. It's staying at plus 0.26. So if I give this, it's on the negative side. So if it's on the negative side now, half a volt, that means it's going to be a pretty good sized bump, but it takes a long time to get there. But it keeps going negative and both of these are going negative. So when this chip is just sitting here, not actually turned on, because this chip is not actually turned on unless this Q102, which is a FET, when the gate on this FET ever goes negative, it turns that FET on and turns on these chips. What's the FET look like? Source. Let's go back over to the manual. And the FET is right here. Here's the FET. So that's, I think that's the FET. Is that one? Yeah, 102. So the drain, the source, drain, gate. Here's my gate is like a minus 11 volts. My source is negative 0.7. All right, so this thing is turned off like it's supposed to be. All right, so all right, so that'll go high. Now, when I turn this thing on now, because it's come way down. Let's see, where are we now? We're negative 1.4 volts. So when I give it its audio, is this thing still working? Yep. Amazing. Give it its audio, see what it does. Holy, there it went. So we've proved it. Even though it looks like it's doing what it's supposed to be doing, it's fooling us because it's not actually doing what it's supposed to be doing. So that's an LF353. So what we got here is a chip that when it's not actually working, and it's not warm or anything, any warmer than normal, when it's not actually turned on, it slowly leaks to negative voltage on both the inverting and non-inverting inputs and output. That's just weird. Let me see if I got an LF353. I'll be right back. Okay, I checked. Yeah, I found one. So let's take this guy and put him in place of U105. Different brand. Signetics. But there we go, LF353. Let's make you work again. Okay. And turn you on. And we'll give it some voltage and see where some audio and see what happens. Everybody is on. Yes, everybody is set. We're on full leveling, and the new chip is in. So let's see what happens when I do this. Ready? Here we go. Okay, they both did it at exactly the same rate. And they didn't go completely skyrocketing out of sight. So let's, that was actually 4 volts. So let's take our meter and look at this guy now and see what we got. Meter, there we go. It's sitting at 0.48 and dropping. This one is sitting at 0.41 and dropping. I mean, that's what they do. It takes them a while to recover, but that's what they're supposed to do. 0.43. So let's see. Let's watch this for a little while and see if it goes negative. I bet it doesn't. It's going to take a minute. It's going way, 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 way slower than it was before. It should kind of level out at about 0.2524, somewhere around there. Oh, boys and girls, that's a weird one. That is strange. A leaky op amp. But only leaky when it's not working. Wow. Okay. I'm just going to let this thing go for a while. Stick the probe there. Let it sit. I'll fast forward through this, and when it gets down to where it needs to be, we'll come back in. Wow. Okay, we're back. I'm not going to go any farther. This thing's down to 0.2 volts. It would have been well negative by now. If we look at this one over here, it's at 0.39, still dropping. But eventually they'll go down with the inputs 0.39 and this input 0.35. This one is 0.18. Could just be the different amps too. 0.18, 0.17. If we look at 6, remember, where is it? Manual. If we look at 6 over here, where it combines those voltages, that DC and L Pin 6 of 106, so that's there. We have no voltage. I'll show you here. Yeah, so pin 6, we have no voltage there. So what I'm going to do, since this is a little bit different and it actually kind of requires it to be more like the others, I'm going to take one of this, the one out of here, we know this is good because we did it, and put it in something that's not going to ever go off. I mean, it just doesn't much care. Let's turn this back on. See what our voltage is now. There. So it's going up to 0. This one went up to 0. Okay, that's what it's supposed to do. So let's watch our output. Turn you back on. Yeah, it turned itself completely off. Okay, so let's give it some voltage here and see what it does. What voltage? I keep saying that, some audio. So we'll give it 3 and watch that top one and see what it does. Exactly what it's supposed to do. All right. And then when I take the audio away, drops back down. And yeah, this particular one, quite a bit faster about doing its thing, but it's 0.36, and this side 0.27. I can go with that. 0.35. Okay, I can live with that just by differences in the chip themselves and maybe some surrounding components. Make sure that my levels are about right. Yeah, input. Yeah. They are right dead on 0, as you can see. So the levels are fine. So replacing this chip did not change anything. If I go to output level, they are the same. No, that's gain reduction. That's input. That's good. That's output. That's good. And that's gain reduction. That's good. So I don't even have to mess with these guys. These are the levels of your meters, a little bit of a swing to get them going. So these are correct. And if I push this button, you should see the enhance bring it up just a little bit on the little camera. There it is. If it's still recording, it is. And back down. So that's the stereo enhance. And we want to make sure that the silence threshold, make sure it's on -40. So let's take away our audio, and they should pop on, and they did. Okay, so that's all working, and beautiful. All right, well, there you go. Wow, that was strange. That's a weird one. A LF353 that's only leaks when it's not being used. Okay, that one, I think I'm going to frame this one, hang it up on the wall. Anyhow, hey, thanks guys. Thanks for stopping by. Don't forget to subscribe and hit that button down, that bell down there if you want to see me do more of this stuff. And don't forget, I've got a Patreon channel if you want to support me over on Patreon. That would be great. And so I can do more of this stuff. I mean, so this does get kind of expensive doing this stuff, but and I'm also over on Odyssey, so AERV blog on Patreon and Odyssey. So thanks for stopping by. Remember this one. This is weird. Till next time.